Okay, I'm just gonna do another update on this non-commutative time frequency. So I was just looking into the Poisson or the Planck's constant, and I figured there's got to be some other definition of it due to non-commutativity. And sure enough, I just found this this graph, because they're saying that the ground state of a wave as a vibrating string is actually the octave because of the Fourier time frequency uncertainty. It has to be 1 or equal to 1 or greater. So it can't be 0. So you have to assume that time already exists. And so because of that, you get the ground state already having this non-commutativity at the octave. So you end up getting the 0 level having a shared value instead of it being 0. So this would be like your perfect fifth that's non-commutative to the 0 value for Planck's constant. In other words, instead of assuming you're having a symmetric ground state of the energy, you're having this non-commutative alternation of the harmonics. And so this is the ground state for 0, because it's over a sphere. So in other words, this h bar is already a 1 over pi 2 as the circle. That's what h bar is. And then you have the w here is the angular frequency. So then you have the pi 2 times 2, which would be 4 pi, which means it's a surface of a sphere. So that's why you get the non-commutative Bloch sphere between position and momentum, or else it's between time and frequency. So to update Planck's original postulate of the constant, the term must be added, and so you get this figure 3, and that you get a non-null ground state energy due to the non-commutativity, and the updated Planck constant reproduces the results obtained by Planck and modern quantum physics. So then they go back to the black body energy, and so they're using the Moyal star product, which is a non-commutative. So I'm just trying to translate this into normal English. And so the number of photons with the frequency and the polarization. So there is the non-null ground state energy. So the introduction of the non-commutativity induces non-null ground state, and consequently you get Planck's radiation law. Unfortunately, this information is not presented in basic modern physics textbooks. It's important to notice that the molecules on the black body cavity boundary, a conducting surface connected to the thermal reservoir oscillate and consequently emit electromagnetic waves that propagate through the interior of the cavity and then hits the internal surface of the cavity, transferring energy to it. Let's see. These molecules behave as charged harmonic oscillators. Indeed, okay. And the limit decreases to absolute zero. The 0 point. Since at the absolute zero, the quantum realm strongly prevails. Okay. And another example is the Casimir effect. Casimir force does not vanish at absolute zero. It's explained okay, we present an alternative way to fix n equals 2 in equation, and consequently the correct ground state energy, whether for radiation fields or oscillating fields, is obtained. Conclusion: the star product among the phase space was applied to the process of determining determines the quantization of harmonic oscillation. A non-null ground state was obtained, and the original Planck's radiation law was extended to embrace the non-null ground state. And the noncommutative term h bar times angular frequency divided by n should be null, but in this scenario we argue only the vibration mode's integer multiples of the wavelength remain. Then the quantum contribution due to the star product disappears. The star product reduces to the scalar 1. The non-commutative contribution disappears. Okay, so now, okay. The existence of the non-ground zero state is due to the existence of a boundary. In the papers, the ground state was obtained. We get the same results by extending Planck's postulate using noncommutativity. There are at least 5 distinct descriptions of Planck's law, equivalent when compared at the experimental level. This shows that the realm for deciding which theory is correct is not only at the experimental level, but also at the theoretical level. Okay, so I just wanted to show that image because that's pretty much the same like music theory secret that I was talking about, that I've been focused on. Is that instead of having, he's comparing it, they're comparing it to this image. So this would be normally your ground state energy. You'd have n equals 0, right? And this is how you learn logarithms, is you have a 0 value, and that's how you learn commutative mathematics, is you use the 0. But they're saying no, that this is not accurate. You cannot have that 0 to 1 or 0 blah blah blah. And that's exactly what I've been showing with the non-commutativity. So when you look at the actual music theory, because of the non-commutativity, you never can get this 0 as the root tonic. In other words, you can never say 0 to 1 is the actual root tonic, because the inherent non-commutativity of the overtone and undertones at the same time creates this infinite energy dynamic. So this is the point of this paper, is that the actual ground state, because of the non-commutativity of the sphere, of the quantum sphere, and this is what Alain Kahn is explaining too, that the truth of music theory is actually this quantum sphere. So you have this inherent dynamic of the energy at the 0 point state that you find in the Casimir effect or in the black body radiation. And so it's fascinating that basically you have to start with this string already up and with the center. And so this is the octave right here as the ground state. Because of that sphere dynamic, you're already getting an octave as the non-commutative ground state, which in music theory it's the same pitch. But since it's asymmetric, then when it goes into the third harmonic or the second overtone, or the second harmonic or the third overtone, you get this different different resonance of so it's essentially like 2 halves or 3 halves. 3 halves or 2/3 would be a different value. And so it just keeps continuing like that infinitely as the foundation of reality. And the fact that there's no 0 ground state means that you have a non-local energy force that the Casimir effect is demonstrating. So it's pretty fascinating. Let's see. So yeah, they're just pointing out that is the truth of the non-commutative. That Planck's constant actually is non-commutative as the average energy of light. So there's no like 0 value of the energy of light, even though, let's say, so you're basically saying there's no 0 for time, even though normally the physics assumes a 0 in time. So then somebody did their whole master's thesis on the non-commutative Poisson tensors. And I don't know, this might have been one of the co-authors of the paper. Doesn't look like it. Let's see. Authorship. Oh, de Andrade. That guy's name is familiar. I'm going to just see who cites his work. This is who cites this paper. 5 versions. It hasn't been cited by anybody. 2023. It's pretty recent. So a professor was one of the co-authors. Okay, this is obviously very technical. It's his master's thesis, so I'm not going to go into that. It's a different topic, but it's related. So, but yeah, I just thought that was a fascinating image. Anyway, I thought there might be something else on there, but so noncommutative derivation of Planck's radiation law. Journal of Physics Teaching. The Planck radiation was capable to explain the black body spectrum, an ad hoc connection between energy and entropy, carried on discrete units of energy. Energy quantization in linear and frequency was introduced. It was introduced by Planck in an incomplete way because the ground state energy was assumed to be null. This issue has been solved in different ways over time, even by Planck. Despite this, we propose an alternative way to restore the non-null ground state due to noncommutativity. We will show that the non-null ground state energy naturally arises as noncommutativity. So, very fascinating. Just want to go back to this image because it's like this image says it all right here. A lot of this is what Basil J. Hiley uses this math. I'm almost surprised, like, do they even reference Basil J. Hiley? They should, but he hardly ever gets referenced. Yeah, they just reference the original. That's too bad. Anyway. So they have it up on Wikipedia. Wave functions of a quantum harmonic oscillator. Okay, so I'm just going to say, let's see, 30. Okay, due to this mode, alright, figure 3, we would like to point out is also due to the non-commutativity. So this is a standard result. It's just that they're pointing out it's actually from non-commutativity. Oh, interesting. So when we search this wave function of a quantum harmonic oscillator, okay, wiki. Okay, so then we have Planck. Alright, so H bar is the reduced Planck's constants. phonons. Okay, so alright, David Griffith. Yeah. External X quantum harmonic oscillator. Here it is right here. So some trajectories of harmonic oscillators according to Newton's law and according to Schrodinger's. So Schrodinger is C to H, right? And Newton's laws are A to B. Yeah, so you have this automatic complementary opposite. The horizontal axle is position, the vertical axle is real or imaginary in CD, but not G and H. G and H are eigenstates, and H is a coherent that approximates the classical theory. Interesting. Okay. So you always have this phase delay. This would be like the non-commutative phase difference. Corresponding probability densities. Alright. Okay. So this is what's interesting is so that see the non-commutative gets canceled out for the probability densities. But what Basil J. Hiley is pointing out is that this non-commutative resonance does not get canceled out because it's non-local from the future. So normally they would just say that that's just mathematical, and so it doesn't exist. But what the Bohm and de Broglie pilot wave model is saying that the future, because it's non-commutative, it's in Planck's constant right there, is the future overlapping with the present. So instead of just getting this up probability density for a particle, you get this phase wave from the future that's guiding the particle as a quantum undertone. So it's sort of like a negative frequency from that's time reversed. The lowest, called the ground state, is not equal to the minimum of the potential well, but Planck's constant h bar divided by 2 above it. This is called the 0-point energy. Because of the 0-point energy, the position and momentum of the oscillator in the ground state are not fixed, as they would be in a classical oscillator. but have a small range of variance in accordance with the Heisenberg uncertainty principle. So the whole point is that this uncertainty principle actually originates from the non-commutativity in the time and frequency. So they're just saying that that actually exists in as the truth of Planck's constant. And that's what I was looking for, is that this, they go into the whole mathematics of it, which obviously I'm not even touching at all, because it's complicated mathematics. But it's the whole idea is to understand the concept of it, that's actually the truth of music theory also, is that 0-point energy. So it's pretty fascinating. So, okay. Yeah, I feel corroborated, because I even have this in my one of my papers. I have this, and I say, oh, this is a problem. This, you can't just have this 0 from whatever value. You can't start at 0. That it creates a logical paradox. So I'm glad that quantum physics says the same thing. It's interesting that they ignore the non-commutativity as the formative cause, is what Basil J. Haley calls it. Let's see if this person, this person might they might reference Basil J. Haley. Let me just see. Information. No, well. So I guess there was people doing similar work as Professor Haley. It's just he was coming at it from the Bohmian understanding of quantum physics. Alright, I'm going to leave it at that.